Hello everyone, let's look at Leetcode question 256, paint house. At time of recording, this question has 2.2 thousand upvotes and 129 downvotes. So in this question, you're given a row of n houses where each house can be painted one of three colors, red, blue, green. This is represented by an array of three values. The costs of painting each house with a certain color is different. You have to paint all the houses such that no two adjacent houses have the same color. An adjacent house, for example, in this problem here would be 2 and 16 and 3. These are all adjacent houses. 17, 16, and 14 is also adjacent. And finally, 17, 5, and 19 is adjacent. So we can't add these values together. These are adjacent. So we need to return the minimum cost to paint all houses. Alright, so in the arrays, like I mentioned before, they're ordered in the costs, also in color. So the first is red, the second is blue, and the third is green. Red, blue, green, red, blue, green, red, blue, green. So we need to add one value from each array and add them all up together so we find the minimum cost to paint all houses. Let's look at the constraints before going into depth on this example. So we get the constraints costs.length equals n. Costs I.length equals 3. These are the three different colored houses. And the n value, length of the array, will be between 1 and 100. And costs at ij will be between 1 and 20. So let's look at the example. Okay, to solve this problem, we're going to reference this first example again, and the code is the following. So we loop first through I in range 1 to length of costs. So we skip the first array index and go straight away to the next one. This will allow us to compare then the first to the previous array. So we can find the minimum between the current index value and its non-adjacent previous array values. So you see costs at I0 is 16. And we want to add to it, so we modify this value with an addition property between the two non-adjacent values, which is I minus 1, 1, that is 2, and costs I minus 1, 2, that's 17. And we see which one of these two is the smallest. 2 is clearly the smallest, so 16 plus 2 becomes 18. Next we have 16 again, but the non-adjacent values are now 17 and 17. So we do 16 plus 17, and this is 33. And now finally we have costs I2, which is 5 here, and their two non-adjacent values, if you look at the problem down here, it's 17 and 2. So which one of these two is smaller? It's 2. So 5 plus 2 is 7. So 5 becomes 7. And then this allows us then to loop to the next array value and do the same comparison with the updated values. This allows us to then calculate the minimum costs while updating the array values. So the first value again is then 14, costs at I0, and we want to find the minimum between I minus 1, 1, and costs at I minus 1, 2. So that simply means that their non-adjacent values are 33 and 7, these two. And we see that 7 is the minimum, so we add 14 plus 7, that is 21. And then we go to the next value, costs at I, which is 2, so cost 2, 1 plus equals the minimum of costs I minus 1, 0 and I minus 1, 2. That is these two values, 7 and 18. So 3 plus either 7 or 18. 7 is smaller, so it's 3 plus 7. Okay, so 3 becomes 10. And finally, the last value, costs at 2, 2. We see then that their adjacent values are 18 and 33. So 19 plus 18 is, let me do the calculation, 19 plus 18, that's I think 36, 37, yeah, 37. So we finally looped through all the values of the array, and now we can return the minimum costs at -1. This is simply the smallest value found at the last array index, which is 14,319, which became 21,1037. So the smallest value of these three is 10. So we return 10 in this example. Okay, let's check the solution to see if it works. Alright, it works. Perfect. Dynamic programming solution. So what is the time complexity of this code? So the time complexity of this solution is O of n, where n is the number of houses. This is because we iterate through the cost list once, updating the costs of each house based on the minimum costs of the previous houses. The space complexity is O of 1 because we are not using any additional data structures that grows with the input size. We are modifying the input list in place. So that's it for this problem. Thank you for watching.